friction.
All right, here we go. Next friction example question. Here we go. We have two sleds tied together with a rope, as you can see down here. The coefficient of static friction between each sled and the snow is 0.22. A small child is sitting on sled 1 with a mass of 27 kilograms, and a larger child sits on sled 2 with a mass of 38 kilograms. An adult pulls on the sled. So the adult is pulling from over here, pulling on this rope here, and we don't know how much force the adult is pulling with. So part A says, what is the greatest horizontal force that the adult can exert on sled 1 without moving either sled? Okay, so when we look at these types of questions, just like we did last week, when you're considering the applied force, which is sort of moving the whole system along, you have to consider the whole system. And so the first thing I'm going to do is add the masses. So the mass, let's call it MT for mass total, is 65 kilograms. And which means that the normal I should probably draw a free body diagram here. So we've got force applied to the right, force of friction to the left. And in this case, because it's asking what's the maximum force the adult can apply without moving either sled, basically we want it so that the frictional force is as big as possible and is exactly equal to the applied force. Okay, and we've got the normal force and the gravitational force, and of course these are going to be equal just like normal. Now we want to find the normal force because that's related to friction. So the normal force equals mass times gravity because it's equal to Fg. So 65 times 9.8 is 637 newtons up. So therefore the frictional force is mu times Fn, which is 0.22 times 637, 0.22 times 637, which is about 140 newtons to the left. Okay, so the maximum that the frictional force can be is 140 newtons to the left. So therefore, if the adult pulls with exactly 140 newtons, then the sled won't move. And if they increase their force just a little bit, that's when it's going to start to move. So the answer to this question is 140 newtons to the right. That's the maximum force the adult can pull with without moving the sled. That was part A. And now part B. Okay. Calculate the magnitude of the tension in the rope between sleds 1 and 2 when the adult exerts this greatest horizontal force. Okay, so let's see. I'm going to draw a free body diagram of sled number 1. So let's see. The adult is pulling with an applied force of 140 newtons. We've got normal force and gravity. Those are going to be equal. And then to the left, we have two forces. We've got the force of tension of the rope connecting the two sleds, which is right here. And we've also got the force of friction. Okay, so now here's the thing. The force of friction here is not the same as the force of friction from the first part of the question, because now we're just looking at the individual frictional force acting on sled 1. So it's actually going to be less, which means that we also need this tension force to make up for how much we've lost in the frictional force in order to still balance this applied force. Okay, so the frictional force here is mu Fn. So 0.22 times the mass, which is the little girl's 27 kilograms, times 9.8. Okay, 0.22 times 27 times 9.8 is 58.2 newtons. So therefore, let me just write this out kind of with a statement. Come on, lead. tension force plus the frictional force must equal the applied force. We don't know the tension force, we're going to solve for it. So the tension force plus 58.2 must be equal to 140. And so therefore the tension force must equal 81.8 newtons to the left.